Hello everybody. So I've had this Land Rover for about 4 years now. Been using it a lot for camping. It's a 1972 Land Rover Series 3 gas engine. Been using it for, driving it for 2 years. It took me about 18 months to restore it. And use it a lot for camping, and I've been pulling a off-road camp trailer with it, and it really needs a little bit more horsepower with all the camp gear that I put in the back of it, and all the camp gear I have in the trailer as well. So I'm doing a horsepower upgrade. I'm using ACR's Power Plus additions. I'm putting a new cam in it, a new high compression head with larger valves, porting, CNC machined ports on it, putting a SU carburetor with a new manifold, and putting tubular header exhaust on it. So this should be cool, and I'm looking forward to having 40 plus more horsepower on this Land Rover, because I love driving the Land Rover. It just feels a little unsafe on the highway when I get out there, trucks all around me. I got to go into the truck slow lane when I'm going up hills. I don't need the speed. As a matter of fact, I don't want to go any faster than 60 miles per hour. However, I would like to get up hills without going all the way down to 45 miles per hour, having all these high-speed cars flying past me. It just feels a little unsafe. So I want to make it safer. I'm probably also going to be putting some disc brakes on it all the way around. So more to come, but I'll just keep you guys posted on where we are with it, and you get to see what the installation looks like, a few of the key points to installation, and so we'll take you through it. All right, take care. Okay, so before we get started, I just want to say a few things about automotive component remanufacturing, or ACR. So Shayla and Roland Marlowe are the people I've been working with at the company in England, and they have been nothing but extremely helpful, not pushy, yet very helpful when I had a lot of questions, because I tend to be that way. And but anyway, I just thought I'd show you. I would just want to kind of introduce that company to you, because that's the company I went with in England to get these remanufactured parts. So I laid them all out here, with the exception of the headers. I'll show you those in a little while. But so this is the head. I already painted it with my engine color. You can see here I'm almost ready to go with this, with the engine. I have to fit the head first to see if I have any clearance issues. But anyway, this is the head. Really nice quality work done on it. Looks brand new. I looked at the porting he did on it, and I think Roland's the guy that does all the machining. He's got CNC equipment there, but the porting looks really good. It's definitely high quality. It's not just the porting coming out of the other side of the head here, but there's also a lot of work done right at the valve area. And so anyway, very pleased with that. The cam, definitely better quality than what I had in there before. I rebuilt this engine about 7,000 miles ago, and I felt like I needed more power, but I also had some issues with the rollers wearing prematurely, and the cam wearing, and this cam definitely is better quality. I can just tell by looking at it. I'm a machinist, I'm an engineer, I know what good quality is, and it's definitely better quality. I can see that he put PFTE, I think it's PFTE coating on the bearing surface of this carrier for the roller, and that's adds lubricity to the surface, so that roller doesn't stall on there and stall on the cam and wear out. But something that's really important to point out that I noticed on the two cam lobes and rollers that wore out in my previous build, when I looked at these sleeves, this hole right here was not centered with this slot. So what happened was it was clocked in the bore, causing the roller to not engage perfectly in parallel with the cam. So that definitely is going to cause skidding, and I'm pretty sure that's what happened, because both number 1 and number 5 rollers that wore out, those two cylinders or sleeves were the ones that had the worst positioning of that hole. So that's something to look out for. Roland said he hand selected these, plus they're new old stock, I think he said. So I'm very pleased with that as well. This is the new intake manifold, ready for the SU carburetor. Nice casting, nice blending of the flash and probably the vents and all that. So, you know, really looked good. This appears to be a steel. This right here is for to keep the manifold from freezing up in the winter months. You run the coolant line through that. One thing that I think I would rather see is stainless steel. That's not stainless. Apparently, it doesn't look to me anyway. At least it is magnetic. So maybe a low-grade stainless, not sure, but I don't believe it is. Anyway, I'm happy with this manifold because I was hoping that it would have a nice fit and finish. Didn't check the fit yet, but the finish looks great. Of course, you get the gasket set there, instructions. All of this came with it here, and then of course the SU carburetor, which I love. Can't wait to see how it performs. But it, you know, just the quality of this carburetor is just worth mentioning and worth talking about a little bit, because you know they don't have to put all this effort into polishing up the bowl, and anyway, you can just tell quality when you have it in your hand. So, and then some fittings, and then the air cleaner. So I will get to the header here in just a minute. The header. So it looks cool. I expect it to work very well. Looks like it's going to be very good flow. I will tell you, I measured the bores for the intake and exhaust, and they are larger for better breathing. Doesn't look like he opened the exhaust too much. I know you need some back pressure with the exhaust for torque. So I think he put all that into consideration. He seems like he knows what he's talking about. He knows more than anybody else I've ever talked to about these things. So he definitely has been around and knows something about getting power and performance out of engines. So anyway, that's what I bought, and that's what I'm going to have on my Land Rover pretty soon. So take a look and you'll see that I took the fuel pump off. You need to do that to work with the cam, get the cam in or out. So it's very important that you have your number 1 and 4 pistons at top dead center. So I used a dial indicator to get it right on. I can also see that the key is straight up on the crank. And so now what we're going to do is take 2 of these dial indicators with the cam followers in here, and what you want to do is get the cam to where the intake and the exhaust are overlapping. And also Roland told me that if you have the cam wheel with only 1 keyway slot, you're probably not going to find the optimal position for timing. So I tore apart another engine and got a 6 keyway cam ring out of there, or cam wheel. This is the single keyway, and that's what I had in the engine because I rebuilt it, and that's what came with the parts that I bought. And this is an older style with the 6 keyways. So to find the optimum position, you have to find the optimum keyway for that position of the overlap of the cam lobes. So that's what I'm going to be doing now. I don't know if I'll be boring you with the time it takes to do that, but you'll maybe when I'm done putting the chain in there and the wheel, I'll be able to show you where things are. So this is the PFTE coating that I was telling you about earlier. It adds lubricity. He put it not only in this load-bearing area here, but also where these parts tend to wear are on the sides here. So he coated those areas where you have high wear. And this, I think it's actually a really good idea to use this. And, we'll see how it works, but I'm convinced that it's a good idea. Roland said that ever since he's been doing that and making sure that the sleeves are drilled properly, that he hasn't had issues with the rollers or the cams wearing out anymore. Okay, so you're going to see here that I have the intake and exhaust lifters. Roland says around or approximately 17 thousandths of an inch overlap. I'm getting about, if I can get the glare out of here, I'm getting about the 16 thousandths. You can see here one is falling as the other one is lifting. I'm turning the cam now. So it's looking like it's you're supposed to get them at the same height, and I'm getting that around 16 thousandths of an inch, as you can see there. Okay, so with some trial and error, I found the best position for my cam wheel. Normally it would be the key would be on the P slot. You can see that I found the happy spot for the cam wheel here. I vibropined it in there just so I have a quick reference if I take it off and put it back on. Roland said to err on the side of a tight chain, so that's what I did, and you'll see here these are my dial indicator readings. So it's slightly rotated clockwise, ever so slightly, a few thousandths difference there. So I think I'm really good in this spot. I think I'm meeting the requirements that Roland has written in his instructions. But yeah, you're gonna probably need the 3-key cam wheel, just because I did a lot of trial and error here. I tried each one, and this particular slot seems to be the happy spot for the cam wheel. So as I stated earlier, because the compression ratio has changed from 8:1 to 9:1, the head had to be milled, and in doing so it lowers the head. So this area on the head, there seems to be quite a bit of interference. I was surprised how much I actually had to take off. It's a close fit anyway, before the head gets milled, so you can see how much stock I had to take off. I'm going to prime and paint it now, but yeah, I was surprised, but it seemed to work out okay. The instructions tell you to do this, to try fitting the head without the gasket, so you can check to see for this interference, and you can't have any interference. I used a feeler gauge underneath it, about a 1 or 2 thousandths feeler gauge, with the bolts just loosely put in, without the head gasket.